So in the second part of this unit, students will be able to recite cosine and sine values for various angles of the unit circle. And our essential question is our ability to explain the relationship between special triangles and the points that occur on the unit circle as a result of them. So here we have our unit circle. All right, it's a circle with a radius of 1. So I'll go ahead and label our radius as 1 here on both sides and actually up and down. All right, so r equals 1. And we know that the entire circle is 2 pi. It's also 0 because it's where we start. All right, and we know on the other side, half of the circle makes it pi. All right, so we have half of a circle being pi. And using just what we know there, we're going to try and generate as many of the remaining lines as possible. So let's take a look at just the top half of our graph. All right, so I'm going to block off that bottom half, and I'll change colors back to black. All right, so if I know that pi is on the left-hand side, if I cut that in half or fold that in half, I get this line up here, which must be pi over 2. If I then were to fold that half again, I would get lines here and here, and those correspond to pi over 4 and 3 pi over 4. All right, think of them as fractions. So we've got half of a pi, a whole pi on the left, we've got a fourth, 2/4, 3/4, 4/4. All right, now we could also divvy it into thirds, and for that I'll change colors into green. All right, so if I were to split that half circle into thirds, I would have 1/3 here, 2/3 here. So we would call this one pi over 3 and this one 2 pi over 3, with the understanding that 3 pi over 3 would be the same thing as 1 pi. And lastly, in red, I could take those thirds and cut each of those in half. So I would have a line here, here, and here. If I cut a third in half, I'm going to get pi over 6. I would get 2 pi over 6 being on the pi over 3 line. 3 pi over 6 is right up here. That's going to be the same as pi over 2. 4 pi over 6 is, again, the other green line, which leaves this one to be 5 pi over 6. And then lastly, pi at the bottom. Now, I can continue to do the exact same concept with the bottom half of my circle. All right, so if I were to continue with my red lines, I would just mirror image them. So I'm going to have a line there and a line here. If I did the same with my green ones, I would have one down here and one down here. And if I did it again with my remaining black lines, I would extend those across in that way. All right, so we're just going to continue counting with whatever value was their base. So for the black lines, we had 1/4, 2/4, 3/4, 4/4, which means this one must be 5/4. 6/4 is going to be down at the bottom, and 6 over 4 is the same thing as 3 pi over 2. And our last one would be 7 pi over 4. And ending at our 2 pi, which would be the same thing as 8 pi over 4. At our green, we've got 1/3, 2/3, 3/3. That means this one down here must be 4/3. This one must be 5/3. And lastly, ending at 2 pi, which would be 6/3. Counting by sixths, I've got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. This must be 7/6. 8/6 is the same thing as 4/3. 9/6 is the same as 3 pi over 2. 10/6 is the same as 5 pi over 3, which means our remaining should be 11 pi over 6, because 12 pi over 6 is again going to be 2 pi. Okay, again, I can do the exact same circle, but with degrees. So here we've got 0 degrees, or 360. All right, which means that my half circle is going to be 180. And then I can just break it down from there. So let's look at just the top half. All right, and I'll go ahead and put it back in black. So half of 180 up at the top here is going to be 90 degrees. All right, I can cut 90 in half and get 45. And on the other side, if I cut 180 in halfway between 180 and 90, I'm going to get 135. All right, and then if I wanted to, I could have cut in thirds. So if I were to cut 180 into thirds, I would have 60, 120, and 180. And lastly, if I wanted to cut each of those into halves again, I would have a half here, half here, half here. That would be 30, 60, 90, 120, 150, and 180. All right, and if I wanted to continue this on to the bottom half here, I'll go ahead and extend each of my lines. So let's go ahead and add in our 45s. And then I'll add in my 60s. And lastly, I'll add in my 30s. All right, so if I were to continue the count, we'll go ahead and do the harder ones first with our 45s. So if I add 45 to 180, that puts me at 225. If I add 45 again to that, I'm going to get 270. If I add 45 again, I'm going to get 15. And then if I add 45 again, I'm going to get 360. All right, so if I were to do the same with my green, my 60s, I went from 60, 120, 180, then I'm going to have 240, 300, 360. And lastly, if I were to count by 30s, I went 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and lastly, 360 degrees. It's important to remember that each of those angles forms a triangle, and more specifically, it forms a special triangle where the hypotenuse in each case is our r, which is 1. Okay, so here are each of the 3 possible triangles that we can have, either a 30-degree triangle, a 45-degree triangle, or the 60-degree triangle. However, in this case, all of our hypotenuse involve this number 2. And that's not going to work for us because we said that our radius, which was our hypotenuse, was 1. So in the case of the 30 and the 60-degree triangle, in order to get that radius to be 1, I would need to divide it by 2. So I would also need to divide each of its other legs by 2. So I'll go ahead and cut all of those by 2. However, for this middle one, I would need to divide by root 2 in order to get rid of that root 2 in the numerator. All right, and this is where we get to talk about sine and cosine because that's how we get the values that you're going to need to memorize for quiz day. All right, so we're going to take sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse, to generate the x and y values of our triangles. So if I'm looking at my 30-degree triangle and I said I want the sine of 30, I am going to take opposite, which is 1/2, over 1, which is our hypotenuse. So I'm going to have 1/2 being my value. If I were to say cosine, I would look at adjacent, so root 3 over 2 divided by 1 as my radius being my hypotenuse. All right, so we're going to take that and use those to look at these numbers that we're going to memorize for test day. So like I said, cosine is the x value, sine is the y value. So if I asked you for cosine of pi over 4, that means I'm looking right here at pi over 4, and I'm looking for the x value, so that's going to be root 2 over 2. If I ask for sine of 2 pi over 3, 2 pi over 3 is going to be over here, and I'm looking for sine, so I'm looking for root 3 over 2. Cosine of 3 pi over 2 looks like I'm looking down here, and cosine of that would be 0.